Hello to all physics classes there, particularly senior high school or college students in the world. This afternoon or this morning or this evening, I would like to talk about the differences scientifically, heat and temperature. Are they the same thing when you say heat and when you say temperature? Let us have first temperature. Temperature is a measure of hotness or coldness of a body in terms of several arbitrary scales and indicating the directions in which heat energy will spontaneously flow. Therefore, heat is manifested through its temperature because you cannot always touch, taste, smell, or even, you know, notice the flow of heat energy without taking the consideration of their temperatures. Now, let us have the different scales. Who discovered these scales? What particular, measurement? When you say temperature, it's a measured using a device called a thermometer. Okay, there are many kinds of thermometer there, barometer, hydrometer, and so on, because they have to measure in particular, let's say, the water, the boiling point, the freezing point, something like that. Now, the special device is called thermometer. Now, although heat and temperature are related, they are not exactly the same. As I said, you cannot always touch, you cannot always smell or taste even the hotness or coldness of a certain body. But what is the safest is you have to get the temperature, correct? The temperature of that object or the material in order to what? To identify whether the material is hot if it is higher term- temperature or lower if it is cold. Now, Celsius is also called centigrade temperature scale, and it was invented by Swedish astronomer Anders Celsius. He was sometimes called, or called this as centigrade under English system. And then we have Fahrenheit scale, German physicist Daniel Gabriel Fahrenheit. Actually, in Celsius and Fahrenheit, there is a relationship. In Celsius, 100 degrees goes to the boiling point, while in Fahrenheit, 212 goes there. 32 for freezing point, 0 for boiling point. No, 0 for freezing point at Celsius scale, while 32 degrees Fahrenheit for freezing point of water. Okay? So 0 sa Celsius, 32 sa Fahrenheit. Until the 1970s, the Fahrenheit temperature scale was in general common use in English-speaking countries. The Celsius and centigrade scale was employed in most other countries and for scientific purposes worldwide. Since this time, however, most English-speaking countries have officially adopted the Celsius scale. The conversion formula you can use, for example, if you're going to use Fahrenheit, given the Celsius, you have 95 times Celsius plus 32. Where did you get 32? Because that is the freezing point of water under Fahrenheit scale. Okay. Now, for metric system, we have also This is according to Lord Kelvin. He was the first who discovered or introduced to us the Kelvin scale or absolute scale, the temperature scale commonly used in laboratories and industry. In this scale, the freezing point of water is 73 degree Kelvin, and the boiling point of water is 373 Kelvin. Okay, one division is equal to one division in the centigrade. One is to one. All right. So if you want to, change Celsius to Kelvin, just add. How about Rankine? If Kelvin is related to Celsius, Rankine is related to Fahrenheit. That's why Fahrenheit plus 460 is your Rankine. 460 Rankine is the freezing point, while 672 is the boiling point. Now, what is the importance of this? The importance of the different, you know, different scales, because some of the measurement, especially heat measurement, expressed in different measurement, especially heat measurement, expressed in is energy that is transferred from one body to another as a result of the difference in temperature. If two bodies at different temperatures are brought together, energy is transferred. That is, heat flows from the hotter body to the colder. The effects of this transfer of energy usually, but not always, is an increase in the temperature of the colder body and a decrease in the temperature of the hotter body. Let's say in lukewarm water, you have to boil, for example, ordinary water to boil, for example, ordinary water, and then after the water reaches, the boiling point, you transfer that to the normal uh, pail of water. What happens to the boiling? What happens to the boiling point of water when it's already mixed with the ordinary water? The ordinary water reaches also or transferred or absorb, for example, the energy coming from the hot water, and it became what? Lukewarm water. So when two objects at different temperatures are together, heat passes from the hot object to the cold object, and the heat loss by the hot object equals the heat gained by the cold object. So that is how heat energy is transferred.